So, as I said before, my name is Psomopoulos. I am a researcher in the supervised biosciences at SERF, and I'm also in ELIXIR Greece. And in the next few minutes, I'm going to give you an overview of what the DOM operations are. So, first and foremost, of course, everyone kind of knows that now big data and AI is kind of all the rage. There are a lot of articles, a lot of big impact and fancy articles that highlight how important big data and AI are in science right now. Of course, in life sciences, it's quite evident that machine learning is now being used across pretty much any biological area you can think of, from the foundational cell analysis to genome to proteomics, metabolism, fluxomics, system biology, pretty much any kind of aspect of biological research. There are some aspects of machine learning being used one way or another. And this is easily identified if we do a quick analysis of the corresponding publications that actually refer to machine learning. As you can see, we are having an exponential increase of publications that actually list somewhere in machine learning. And this one, although it's not completely up to date, you see it's up to 2021, it's not also complete because it's already restricted to some of the aspects of life sciences. And you can see that from the query below that this can be easily expanded. But even so, it's quite evident that there is a very significant increase, exponential one on publication, and therefore I assume the use of machine learning in that. However, there is a key challenge. And this challenge is that who was identified in 2020, and essentially they did an analysis of a lot of publications, and a lot of them actually did not have any variation. On average, it's 20%, and you can see from the distribution here that there are different kind of splits on that. The interesting thing is it's highlighted from the article in the lower right hand of the slide. 20% is across, and if we consider cases where the articles do not include any computational co-authors, this number increased as high as 34%. So 1 out of 3 publications do not apply any evaluation whatsoever of the machine learning process, although machine learning is being explicitly mentioned as being used in the process itself. What does this mean? It means that if we look at this from the point of articles, and that's a very rough schematic representation of that, we're talking about a lot of publications in absolute numbers that have done like zero cross-validation, no independent test sets, no statistical test, essentially no kind of assessment at the very least of whether the science behind the machine learning actually is valid. They have results, they have an output, but nothing beyond that. So why is this of interest? This is one of the things that have been identified early on from the ELIXIR machine learning focus group. This group within ELIXIR was established almost 5 years ago, and it's currently being led by myself, Silvio Tosatto, and Leia Yael Castro. And the main goal is to identify standards for machine learning, which of course is the focus of today's webinar, benchmarking how machine learning tools can be assessed, how we're talking about reproducibility of machine learning, how can we train people on effective use of machine learning, and of course, being an ELIXIR focus group, how to better integrate machine learning within the wider ecosystem. And of course, the topic being extremely interesting from that day zero, we had a lot of interest across all the nodes. More than 40 members constantly participating, especially in the first few years. And we already have a lot of outputs and publications. Of course, the DOM recommendations is the one we'll discuss today, but we have others around synthetic data. We have now software services. The DOM registry is going to be presented in the next talk, and of course, a few funding projects. Ultimately, however, this is not the thing that we do in a vacuum, and we try to make sure that there is a consistent and bidirectional communication to other communities and other stakeholders, including industry and other international partners. So why are we interested in the standards? And this is where the DOM comes in. So the DOM is essentially a set of recommendations, a set of community-led guidelines that are specifically focused for supervised machine learning and for biology in a context. Although this is defined very succinctly, The premise of the DOM recommendations is easily expandable to other domains. And as I'm going to highlight at the very end of the talk, the plan is to expand it to other aspects of machine learning as well beyond the supervised. But the DOM recommendations themselves focus on the machine learning, or the supervised learning, sorry. It was published in 2021 in Nature Methods. You can see both the DOI and the article here. And since then, it has been accessed more than 20,000 times. It has a few hundred citations. And it's a listed standard on fair sharing, and you can find the record ID here. So what are the DOM recommendations? So the DOM itself is an acronym, stands for Data Optimization Model Evaluation, and essentially it comprises for each of those elements some key questions that one needs to address in order to move ahead. Specifically, if we want to go through those, and I will go into a bit more detail in the next few slides, we are talking about the different aspects of the data, different aspects of the algorithm that is being used before you actually create the model itself, whether it's interpretable or no, and you can already identify a few of the points that have been popping up as challenges earlier in the Menti, and ultimately how can you actually evaluate the model itself? So these are all questions that someone needs to readdress. I'll go through those in slightly more detail in the next few slides, but I definitely urge you to go through the template that we are providing, as you can find this also in the DOM Machine Learning website here. So starting with the data, there are four main aspects. The first one, of course, is the provenance. If I'm going to machine learning, I need to make sure that the data I'm using comes from a particular point of view. In other words, I can retrieve them and have an understanding. And you can see an example of how provenance can be filled in with an article here, and that would be the corresponding response. The data splits is one of my favorite ones because several articles, sorry, tend to completely ignore this aspect. When you're training an effort, you need to make sure that your data are split into training and tested, occasionally also the validation if you want to be more formal, and you want to make sure that these are specifically defined. This goes also to the redundancy. If you're going to split them, are you going to have overlaps? Are you going to be is going to be any kind of data leakage efforts in this idea? So capturing also what is the redundancy with the data splits is a key question. And also, I need to make sure if I want to rerun this, where can I find the data? URL, a license, etc. Moving on to the optimization, this is focusing more on the algorithm itself. The first and foremost, what is the algorithm? The machine learning one that you use, not that I just machine learning supervise something. I need to know what is the algorithm, what are the features, whether it's a meta predictor or not, if it's a consensus of other methods or a algorithm by itself, whether I did any particular encoding in the data itself, and if I use a particular set of parameters for the training process, I need to know which they are, essentially reproducing the model generation process, which are the features that I'm going to use, and whether I did any randomization in the process, and whether I did any kind of fitting, so that I can actually capture cases of under overfitting quite early on. Ultimately, it would be ideal if I have all this configuration as a single thing that I can download and retrieve, hence the availability of configuration at the end. The model is the particular questions of the model that is produced. So for example, is it interpretable or not? For example, if it's a black box, I need to know if I can use this as an input to interpret the model itself. It will be extremely useful, especially in particular context. What is going to be the output of the problem? What is the execution time on a particular setup, computational one? I need to know whether I can actually run and create the model in my traditional desktop in like a few minutes, or whether I need an HPC running for a month. Completely different setup, completely different expectations. And more importantly, make sure that the software to do that is also available, which is kind of a big challenge and a big request. And nowadays, where people are producing machine learning algorithms by a dozen, but not all of them are as easily available for rerun and reuse. And finally, the point that started the whole thing about the evaluation. How did you evaluate the method? Which is the data set? What are the measures that you used? The list, the methods, the comparison to other methods that you may have used so that you have a baseline across different cases. If you had a confidence on your results, some statistical analysis, And ultimately, if you can provide me this evaluation as a particular file that I can download and assess myself automatically through a system. So as you can realize, none of those points and the questions are extremely difficult to imagine. But as you can understand, making sure that all of them are captured effectively are quite important to make sure that the science behind the particular work is also sound. So wrapping up, and that's my last slide, if we want to go ahead, we need definitely to have some standards for AI in life sciences. DOME is definitely one of the established ones so far, and we want to continue to expand it. As it is already an actual outcome of the group, and it is being used and can be used by the wider scientific community across different aspects, different roles, from researchers to publishers to funders, and ultimately to the policymakers, making sure that any kind of machine learning model follows some particular transparency guidelines on the reporting. Moving ahead, what we want to do with the DOM recommendations is to engage with all the stakeholders, all the other communities, and make sure that we promote both the adoption of the standard and the growth, making sure that we expand also to methods of machine learning and also to other domains beyond biology. So with that, I want to acknowledge the entire machine learning focus group, because this was literally a community effort, and it was not one person or a smaller group of people. But also I want to acknowledge the leaders of the focus group for their enormous effort in pushing this forward. So with that, I think I can stop sharing my screen, and I will yield the floor to the next speaker.
I will be talking about the current step where we are with the DOME recommendations, which is the implementation of the DOME registry. So the DOME registry is taking the next step with the DOME, in the sense that we're in the process of being able to turn the DOME recommendations into actual data, which is contained in the registry itself. And this process goes through the following steps, whereby you have the DOME recommendations, you select one or more papers. Ideally, as we'll hear later, this is done with new papers which are being submitted to journals. But for the time being, we are also content to do this with papers which are in the literature. And so we have curators who have been contributing their time and effort to curate those papers according to the DOME recommendations. And this is the information which is then stored in the DOME registry proper. The paper describing this is currently in archive, and it has been submitted to a journal. It should be out fairly soon. For the time being, you can find the archive version on the link I'm showing you there. So the DOME registry itself is rather simple to describe. It is on the outside a web interface where you can look up various papers which are already published and which have a machine learning method which has been described. At the moment, we have around about 200 annotations. Almost 200 of them are public, and then there are a bunch of others which are currently private, because we also have the option for curators to write up something. This is especially useful for papers which are not published but which are in the review process, so they can stay private until they are finally published. And therefore, we have a relatively limited number of entries which fall in this category, which is useful, for instance, to show the DOME recommendation page to reviewers so that they can assess the quality of the paper without this already being public. In any case, currently we have 82 users who have been contributing to the DOME registry, and the actual process, or better, the annotations which are in the DOME registry follow the DOME recommendations themselves. Here you see, as an example, one of the pages for an annotated protein. sorry, for an annotated paper. And you see that we have these cards which describe the four main components of DOME. Each one of them has a set of questions, and you see the answers which are provided to that. And in case one of these questions was not addressed, this generates an invalid field where you can see either no, it's highlighted in a different color. You can either see no, or it can be deselected. And therefore, as a very crude first approximation of trying to gauge the quality or the adherence of a given paper to the DOME recommendations, we have generated a score, which is shown there on the left-hand side, where for each of the four DOME components, we just count the number of questions which have a valid answer and the number of questions which are not addressed. So this gives you a rather unweighted and crude approximation of the adherence to the DOME recommendations themselves. In total, we have 21 questions, and it's just a number of questions where there's something which has been answered. Now, of course, this has a number of limitations, but it already gives you an idea because if something doesn't address at all some of the DOME criteria, there will many of these sections which are flagged, and therefore the DOME score will be lower. In the future, we plan on implementing a more stringent way to evaluate the quality of the entries in the DOME registry. But for the time being, this is what we have. Now, the process itself regarding the annotations of the DOME registry is shown in this overview slide here, where on the top left-hand side, you have the data input, which is handled via the data stewardship wizard. So here we have an input form, which takes the form of a questionnaire, which can be filled out, and this produces some JSON file, which is then submitted via an API to the DOME registry proper. There, the annotation is saved as private, and we are able to recognize the contributions of the authors, which provided this annotation via Epicuron, which is our platform for biocuration credit and recognition. And then once this is released, and this can be done either by the users themselves or via an admin, the annotations are published and are then becoming visible on the DOME registry website so that the users can browse it. And now let me just walk you through two of the main features here, which are data stewardship wizard for the inputting the data and Epicuron for giving credit to the various contributors. Now, the first part, the input of the data is handled via the data stewardship wizard, which is a rather flexible tool, which uses a knowledge model, which you see there shown on the left-hand side. And essentially for DOME, it's the four major component, data set optimization, model, and evaluation, plus some metadata, which would be the publication. So in order to unambiguously identify where it got published, and the user who has been contributing this type of information, as well as some housekeeping fields for the annotation proper. Then the user would have to create a new project and input via a series of questions. The answers to this would be the data which gets stored in the DOME registry itself. In order to facilitate this process, we have already created a video which is available via YouTube, and the URL is shown there on the bottom, so that it's quite easy to complete one of these DOME entries and make sure that you have them properly represented. This is the input of the data, and then the one element we have in order to try to have more people contributing this type of annotations, we do leverage the Epicuron platform. So whoever creates and annotates the entries for the DOME registry can get recognized via Epicuron as a contributor to the registry itself. So Epicuron works in a way that it provides a general purpose credit and recognition framework. DOME is already registered as one of the member databases, so you can have profiles for the various people contributing to DOME. And as you see on the bottom right-hand side, we have a leaderboard of the people who have been contributing more to the DOME registry itself. So it allows us to capture the contributions and to give credit to this whenever this is due. The DOME widget is from Epicure and is also available on the proper DOME registry website. I think this is a very quick walkthrough of the DOME registry itself. So last but not least, I would just like to acknowledge the people who have been doing the actual work. So the two main developers, the development started with Damiano Clementel, who made the first prototype, and is currently being maintained and expanded by Omar Tafi. Alexander Monson has been contributing to the coordination of this project. And with that, I think I would like to thank you for your attention, and I would pass this on to the next speaker.
Thanks, Fotis, and thanks for having me. I am calling in from Borneo, where I've been at a workshop. Hopefully the internet will stand up. There's also a strange Chinese festival going on outside with like lots of drums going off, but it seems to be quiet at the moment. So I'm going to present a different use case, as Fotis said, but using DOME in the wild really for another application, specifically for publishing. Publishing using it with papers that use machine learning, which is a growing amount, really. So it was great that we started off with the Menti that looked at people's interest, and reproducibility came up as kind of the number one subject. So I'm kind of preaching to the converted here. That we know that there's a challenge. There's arguments over how big an issue it is, but we know it is an issue. The worst case scenario highlighted in some papers, there is replication rates, at least in preclinical cancer research, as low as 11%. Different fields, not quite so bad, but it's definitely a major issue that we need to tackle. It's a massive waste of money, bad drugs, holding science back, really. And so this was a lot of the rationale for GigaScience and GigaScience Press. I'm the editor-in-chief of GigaScience, and we really set ourselves up at the beginning. We launched in 2012, really trying to be a journal for open science, really, to reward the additional efforts to share all of the underlying data, software, computational workflows. We were the first journal in biomedical sciences publishing data papers, for example, and peer reviewing this, crediting this, and trying to make reproducibility the kind of key here. And the other thing that we've been offering really is and are quite unique, is that we almost do open science as a service, because to make this kind of reproducible publishing really work, we have humans on hand. We have a curation team who, as part of the publication process, can basically go through the paper and help check and help the authors curate and make sure that all of the underlying research objects are available. If there is not a subject-specific repository, and not if things are intermediate data types or things are kind of falling through the gaps, we even have our own data repository that since 2011 we've been working with DataCite and give these data sets DOIs, digital object identifiers, that are then cited inside the paper. So this is all, reproducibility has been our big focus. We've done a reasonable job, but these things are never 100% perfect, but at least pushing the kind of boundaries of kind of what you can do and tackle this challenge. But as we've seen in the talks so far, there's the really big challenge in recent years has been the rise of machine learning, that has it's really facilitated so much research, but as the talks earlier mentioned, there's problems with a lack of evaluation, and black boxes, really, proprietary tools. It's just, it works really well, but if you can't really figure out the inputs, the outputs, it's potentially a step back for reproducibility. Almost a big iceberg has suddenly hit hit us, and we've seen a huge rise in the submissions that we get. Fotis showed the graph of the explosion in publications mentioning machine learning. So we're not the only journal that's that are kind of on the front line and having to deal with this. So we've had to really try and change our review process, really try to figure out how to tackle this challenge. So in medical research, there's been as with this explosion in machine learning, there's been an explosion in at least machine learning checklists, AI checklists and reporting guidelines, because so many of these things are basically going into the clinic now. And in medicine, they've been very specialized on particular data types of medical imaging, different styles of and like kind of add-ons to lots of the clinical checklists that are already out there. And if anything, there may be too many standards there. We really need broader and more general field agnostic guidelines, for biological sciences for one, and many other fields, but beyond these medical areas. And they're focused on, but these ones are focused on taking things into the clinic. They're very focused on authors, but journals and the peer review process has slightly different needs. And we want these things to be comprehensive, but not so difficult that it puts people off, and just get unwieldy. And any ways of integrating this with kind of online tools make the process easier, also super useful. So we've been having this issue for a couple of years now, and thankfully Dome has come along. We were very happy to read the paper, and so we've been working with the group here and participating in a lot of the working groups and stuff, to try to see how it works. It's a bit of a trial, really. These are kind of early days, but it's given us actually a tool to that we can at least frame our peer review and this process. It may not be perfect. We may need to kind of tweak things, but it's great we actually have some kind of structure, something to work for. And so as a journal editor, it's been a great initial tool for at the very beginning of the process. So a machine learning paper will come in, and as Fotis mentioned, many of these have no evaluation, many of these have no data, or in some kind of gray area where it's kind of difficult to tell what is there, because they haven't really been thinking about the reproducibility side. So the editors kind of look and say, does it follow Dome? Very few papers so far are already citing it, but does it? We kind of asked the first question: does it look like it's kind of potentially domeable? If it has no chance at all, there's just no data, nothing to review, then we immediately reject it. And so it's been a useful tool in this kind of initial triage discussion. If it looks potentially domeable, then we may go back to the authors, send them the Dome paper, send them the Dome checklist, and say, look, could you add like a few more details here? If it looks close enough, at this stage we're not peer reviewing things, but if it looks like we're getting close, then we send it to the next stage to our data curators. They then have the Dome data stewardship wizard, and we'll work with the authors to then fill out these annotations. If lots of things are missing, there can be some back and forth, but hopefully we have a pretty full checklist there, and then we can go to peer review. And having everything in the wizard then actually aids the peer review process, hope making things easier for the authors as well and the reviewers, that it in a more structured way explains where all of the key parts of the study are. If it then passes peer review, then we can integrate the annotation into the publication. So what does the end product look like? So we will highlight the DOME annotations at the end of the paper in the data availability section. These can link out to the GigaDB entry that we create, and there's a link to the wizard in here. And if you click on that, then you basically see the DOME annotations in the data stewardship wizard website. So this is here for so the reviewers could scrutinize this once it's published. The readers can scrutinize this. If there's a particular part that you're interested in, you can basically go through this and figure out, okay, where is the data, where are the models, how have they optimized and evaluated this. So it they may have missed describing these things in detail in the paper, but it's actually, at least it's here in the associated DOME file. So this is work in progress. But we're definitely seeing that this has been a very useful tool for us. The annotations are super useful for peer review, super useful for the editors, for the future readers as well, to properly understand papers. We've had about 20 papers go through this whole process now. We're currently using everything in the data steward wizard, but hopefully it will end up in the registry. And we would like to thank DOME for providing these fantastic tools, being great partners in this. I should thank our data team, our editorial team, and particularly Chris Armit, who was in the GigaDB team and did most of the heavy lifting here. The ELIXIR machine learning focus group, and all of the authors and reviewers who have used this. So